Hello guys, let's solve the sample problems presented in your study guides in Geotechnical Engineering. Now, before we answer the sample problems, let's have a recap of the discussion on the differences of the four unit weights. The 4 unit weights that you will encounter all throughout this Geotechnical Engineering subject. Okay? Now we have the first one. We have the unit weight or bulk unit weight of soil mass, or that is the gamma M or the gamma moist. So what is gamma moist? Gamma moist is the unit weight of a soil wherein it is in the natural state. Natural state, or the sample was taken on site, NC2, or that is freshly taken from the site. So the condition of the sample is that if you consider, if this is the sample, the soil sample, which has voids, okay. So the condition of the sample is it has its solids, it has the water on the voids, and some voids contain air. So that is moist sample, gamma moist, gamma M unit weight or bulk unit weight of soil mass. Now the second one is the gamma D or gamma dry. Now for gamma dry, from the word itself, dry, if this is the sample which has voids, we will just be considering the solid part. So the solid part of the sample, so it has voids and does not contain any water. So the condition of the sample is that it is zero saturation and zero moisture content. It is the sample that has been taken out from the oven. Okay? The third one is the gamma sat or the gamma saturated. For gamma saturated, the condition of the soil is that the saturation is 100%. So if this is the soil sample which has voids, so we have here the voids, all voids are filled with water, so that 100% of the voids contains water. Now let's go to the fourth one, the submerged or buoyant unit weight, or that is the gamma B or gamma prime. It's also known as the effective gamma. So gamma effective, and buoyant weight, buoyant unit weight or submerged unit weight is actually the effective mass per unit volume when the soil is submerged below standing water. So the condition of the sample is, so if this is the sample and it has voids in it, so some voids contain water, some voids contain air. So does it mean it's the same with the gamma M, since the condition of the sample is the same? No, it's not actually the same. The reason why this gamma B or gamma prime is called the effective unit weight is that the ratio of the solids, the volume of solids, the volume of air, and the volume of water is good and provides structural stability for the structures that is standing on that soil. So meaning the soil sample has attained a strength wherein it can withstand a certain force. Okay? Now, unlike the moist unit weight here, which is taken fresh from the site, it is weaker compared to the effective unit weight. Okay? Now, we're talking about unit weight And in this subject, you will also encounter the density, the moist density. Then you have the dry density, or that is raw D. Then the saturated density and the effective density. Submerged density, rho prime, rho E. Okay? So the only difference is that when we're talking about unit weight, we have here weight, and when we're talking about density, we have mass. So mass over volume. Difference between mass and weight is that for mass, the unit is grams, kilograms, and for weight, we have the kilonewton and pounds. Okay? So I think we have covered that. Okay. Next one is the differences between void ratio, porosity, the water content, and the degree of saturation. These four you will also encounter all throughout the subject. So for the void ratio, the symbol is E. It is the ratio between the volumes of voids to the volume of solids. It is expressed in E is equal to volume of voids over volume of solids, or the dry volume. Okay? Now, how about porosity? Porosity with symbol N. It is the ratio between the volumes of voids to the total volume of a soil mass. And it is expressed in percent, and the formula is volume of voids over the total volume. So what's the difference between the two? Now for the void ratio, it is concerned with the sample in dry state. Okay? So a while ago, we were talking about the dry unit weight, which is taken from the oven, meaning it doesn't contain any moisture, or it is 0% saturation. Now here, in void ratio, we also have the sample in the dry state. Okay? Or that we are taking the, we are considering the dry volume here in the denominator. Now for porosity, the porosity is volume of voids over the total volume of the soil mass. So if we say total volume of the soil mass, meaning it is the sample that is considered, the solids are considered, the water as well as the air. Okay? So that's the difference between the two. Now the relationship between the void ratio E and porosity N is that we can see that in the formula, N is equal to the void ratio all over 1 plus E. So N is equal to E over 1 plus E. For the void ratio, we have there porosity N over 1 minus N. Okay? Now let's go to the next one. We have the water content or moisture content. Same. And it has the symbols MC or W. Now for water content or moisture content, it is the ratio of the weight of water to the weight of the solid particles. So we have here the moisture content is equal to the weight. So W of water, so weight of water over the weight of the solids, or the weight dry. Now we can also consider the mass. So we have here W, or that is also MC, is equal to the mass of water over the mass of dry particles or the solid particles. Okay. Next, we have the degree of saturation, symbol S. Now, degree of saturation is the ratio of the volume of water to the volume of voids. So, S, degree of saturation S is equal to volume of water over the volume of voids. Now, in order to remember this, we take note that if the soil sample is saturated, it means S is equal to 100% or S is equal to 1. So to consider the S as equal to 1, it means this is the soil sample. We have here the voids. So take all the volume, the total volume of the voids, here, the voids here. So you have the volume of voids. If all of these are filled with water, that means the volume of voids is equal to the volume of water. Thus, the answer, if you divide volume of water over volume of voids, it becomes 1. Okay, so that's degree of saturation. Now, the relationship between the specific gravity G, the moisture content MC, saturation S, and void ratio E is that you need to memorize this. We have there G times MC is equal to S times E. So GMC is equal to SE. And as for the porosity, you can get the value of porosity if you get the value of E. Okay? So that's some things to remember so that you can solve for the problems here in geotech. It is going to be useful because we will be talking mostly of these concepts, these terms and formulas. Okay? So let's go back to the sample problems. Let's solve the sample problem number 1. A sample of saturated soil weighs 588 Newton and has a volume of 0.03 cubic meter. If the voids ratio of this soil is 0.75, determine the specific gravity of the solids. Okay, so let's write first the given. It says here that the soil sample is saturated. So if the soil sample is saturated, that means S is equal to 100% or S is equal to 1. Next, the weight of the soil sample is, so what is this weight here? The saturated weight. So we have 588 Newton. And the volume is equal to 0.03 cubic meter. Given the void ratio is equal to 0.75. Then we're looking for the specific gravity. Okay? Now going back to these 4 unit weights here. So let's get from here the formula. Okay, let's erase it for. Let's erase all of it. Okay. So we're talking about saturated soil. So if we're talking about saturated soil, then we're dealing with the gamma sat. So let's copy this formula here. So gamma sat is equal to G plus E all over 1 plus E gamma W. Now what is gamma W, by the way? If we're dealing with gamma W, so unit weight of water is 9.81 kilonewton per cubic meter, or that is 9,810 Newton per cubic meter. Now, if we are using gamma sat, then our this is raw sat. Okay. Then our raw water or density of water is 1,000 kilogram per cubic meter. So that's good to remember because you will encounter them a lot here. Or let's add that one because it will be helpful. We also have here 1 kilogram per liter. Okay? Or that is 1 gram per cc for the density of water. Okay? So let's copy the formula for the water. For the gamma sat, sorry. So for the gamma sat, so why are we using gamma? Why not density? Because we're talking about weight and volume. Okay? So we have here gamma sat is equal to G plus E all over 1 plus E gamma of water. Okay? So we now have here the missing the G. We are also missing gamma sat, and given is given are the E, then given water. So how do we get the value of gamma sat? Remember here that for gamma we have weight over volume, weight over volume. Now depends on the situation. If you're looking for the gamma moist, of course the weight of the soil here is the moist weight. If you're looking for the gamma D, so the W here is the weight of the solids. Therefore, if we're looking for the gamma sat, that is weight over volume, therefore we are considering here the weight that is saturated. So that is 588 Newton divided by 0.03 cubic meter. So gamma sat is equal to, okay, so we have here 588 divided by 0.03. So this is 19,600 Newton per cubic meter. Okay, so we have here 19,600 Newton per cubic meter equals missing specific gravity G plus 0.75 void ratio 1 plus 0.75. Then gamma of water is, if we're considering here Newton, since Newton per cubic meter is used here, so we will use here Newton per cubic meter also. So for Newton per cubic meter, we have 9,810 Newton per cubic meter. So you can cancel this one out and get a value of G that is unitless. Right? So we have 19,600 alpha equals alpha x plus 0.75 over 1 plus 0.75, and then we have 9810 for the water. Ay, it should be shift solved, right? Okay, so x is equal to 2.75, or in our sample we have G is equal to 2.75. Okay, so that's the specific gravity. That's for number 1. Let's go to sample number 2. For sample number 2, we have a clay sample has unit weight of 21.1 kilonewton per cubic meter. So this is cubic meter. At moisture content of 9.8%, Okay? When completely saturated with water, its unit weight is 22.58 kilonewton per cubic meter. Determine the porosity of the soil. So we have the clay sample. It has a unit weight of 21.1. So what kind of unit weight are we talking about here? So we have 4 unit weight. So which one is the unit weight of number 2? Okay, so what unit weight are we going to use? So it's talking about here moisture content. So moisture content, therefore, we're dealing with gamma moist. Gamma moist here is 21.1 kilonewton per cubic meter at moisture content of 9.8%. Then, when it says here, when the soil is completely saturated with water, its unit weight is, so gamma sat is 22.58 kilonewton per cubic meter. Now, if we're dealing with gamma sat, so that is S is equal to 1. So, here, there's no need for us to put there. S is equal to 1. Anyway, if you observe the formula for gamma sat and formula for gamma moist, here, this one here, it's still the same if you put S as 1. See? So if you use S is equal to 1, the formula of gamma moist becomes gamma sat. So no problem. Right? So another given here is, so no, there's none. So we're looking for the porosity N. We're looking for porosity N. That means we need to solve for the void ratio E, just as I mentioned a while ago. Okay? So let's start with gamma M. Let's write the formula for gamma M. For gamma M, we have, so we have here, not that one, because we have moisture content. If you see there, we have moisture content here. So that we can use the value of moisture content, not just this one. If we use this one here, then where is the input for the moisture content? So let's use this one. So gamma moist is equal to G, specific gravity G, GMC over 1 plus E gamma W. Now remember the GMC SE a while ago. So GMC equals SE. So look at this part here, SE, GMC. Okay? So still good. So gamma moist is 21.1. That is in kilonewton per cubic meter equals G. So we're missing specific gravity G plus G, moisture content 9. Okay. So remember that for moisture content, we need the decimal part, 0.098. This is 0.098 over 1 plus the missing E. Then, the unit weight of water as 9.81 kilonewton per cubic meter. Cancel unit. So what we have here is 2 unknowns. So should we panic? No. Remember that in the problem we have gamma moist and gamma sat. So we have 2 unknowns for gamma moist. So we have the unknown as G and E. Same is true with gamma sat. G and E is missing. So we have here 2 equations, 2 unknowns. Okay? So there's no problem with that. So we have here 21.1 plus 21.1e equals G plus, or that's already, okay, 1.098 G. Okay, so let's arrange this as 21.1e minus 1.098 G equals negative 21.1. So that is the first equation. Right? Next, let's have the formula for gamma sat. Gamma sat is equal to G plus E over 1 plus E. So G plus E over 1 plus E gamma W. Gamma sat is 22.58 kilonewton per cubic meter. Okay, so I hope it fits here in this page. So G plus E over 1 plus E. Then here we have, okay, so I forgot there's water here. Okay, so let's redo this one. I forgot something major. Let's divide 21.1 with 9.81. Okay, so 21.1 divided by 9.81 is 2.1509. 2.1509. Okay. Then we multiplied with 1 plus E. So that becomes plus 2.1509 E equals 1.098 G. Then arrange it. So arranging it, we have okay, so we have here, let's put here 2.1509E minus 1.098 G equals 2.1509. That is negative 2.1509. So this is equation number 1. Next we have gamma sat. Gamma sat is G plus E 1 plus E gamma water. Gamma sat 22.58. That is in kilonewton per cubic meter. Then we have G plus E 1 plus E. Then we have 9.81 kilonewton per cubic meter. Cancel the unit. So what is 22.58 divided by 9.81? So we have 2.3017. So 2.3017. Then multiply it with 1 plus E. We have 2.3017 E here. And then we have here G plus E. So we put here the E first. So this it becomes 1.3017 because of this. We deducted 1 minus G equals negative 2.3017. So this is equation number 2. Now let's look for, oops, we forgot here the E. Okay? So let's look for the value of E and G using the calculator. Okay, so this is equation number 1, this is equation number 2. Okay, so we have here mode, and then we have here the what's in the equations. The equations is 2 equation, 2 unknown. So here we have this one, 2 equations, 2 unknown. The first one is 2.1509. Next, negative 1.098. Next, we have negative 2.1509. Next, we have the 1.3017. Next, negative 1. Next, negative 2.3017 equals. So for the value of x, or that is the first one, meaning the E here, so x is 0.5215 or 0.5215. The value for G is 2.9806. 9806. Okay, so what do we need here? We need the porosity, and the formula for porosity is this one. N is equal to E over 1 plus E. So N is equal to E over 1 plus E. So we have 0.5215 over 1 plus 0.5215. N now is equal to there. So N is now equal to 0.5215 divided by 1.5215 equals, so that is 0.3427. And in the problem, does it say there in percent? No. So if the problem says find the porosity in percent, so this becomes 34.27%. But since it did not mention, well, we can still get this first one as correct. Okay, so that's for number 2. Okay, let's go to number 3. A specimen of moist clay has a mass of 183.4 grams. After oven drying, the mass is reduced to 157.7 grams. What is the moisture content of the sample? So it's looking for the moisture content. Again, what's the formula for the moisture content? The moisture content here has the formula. Depends if we are using mass or weight. It says here the mass of water over the mass of dry, or the weight of water over the weight of dry. So it means simply water over dry. So the pure water over the solids. Okay. Now let's write here the data. So a specimen of moist clay has a mass of, so mass, moist mass, so 183.4 grams. Then that sample of clay was oven dried, and then the mass was reduced to 157.7 grams. The reason why it's reduced is because water has been removed from the sample. So that's why it's lighter here. Then, let's solve for the moisture content. Moisture content is mass of water over the mass of the solids or the mass of dry. How do you get the mass of water or the water that is contained in the voids of the sample? So how do you get the value or the mass of the water, or of the mass of the water that has been in the sample? Of course, what you will do here is you subtract the moist sample and the dry sample. Then you have here MD. So moisture content now is equal to 183.4 minus 157.7 all over 157.7. Then we will now be able to get the moisture content. 183.4 minus 157.7 all over 157.7. So the answer here is 0.163. Okay, so the problem did not specify if we are going to answer in percent. So moisture content is 0.163, or that is 16.3%. So that's the moisture content. Simply, moisture content is the water over the solid. Water over dry, water over solid. So in whatever way you can remember the formula. Okay, let's go to number 4. So a hand-carved sample of soft saturated clay weighs 350 grams and has a volume of 200 cc. What is 200 cc? That is 200 cubic centimeters. After oven drying, it weighs 240 grams. Calculate the following: the moisture content in percent, the specific gravity of solids, and the porosity in percent. Okay, so what is missing here is the moisture content, MC, specific gravity, G, and the porosity, N. Okay, remember also the symbols of these terms. Alright, so what do we have here as given? A sample of soft saturated clay. Saturated, S is equal to 1. And the weight here of saturated clay is 350 grams. The sentence says weighs, but it's mass here. Okay, so 350 grams, and the volume is 200 cubic centimeters, cc. So after oven drying, so you dried it. Okay, so this is saturated SAT. Okay, so after oven drying, the weight now becomes, so MB, so that is 240 grams. You remove the water. So calculate the moisture content. So a while ago, we know that moisture content is just simply water over dry. Subtract the wet sample to the dry sample and over the dry sample. Then it's asking in percent, so this is times 100. So moisture content is now equal to 350 minus 240 all over 240 times 100. So 45.83%. That's the moisture content. Let's go to B. The specific gravity of solids. Now, where do we get here the formula for the specific gravity of solids? Now, there is formulas that has been presented a while ago. Okay, so let's try to use that, knowing that we have the given now as S and MC. What we're missing is E and G. So we're missing the E and the G. Now we have the given S and MC. Now, what is now the relationship that you can see from here? We are having the formula G MC equals SE. Okay, let's use that one. So we have here G MC equals SE. So we have here the value for G is none. Moisture content in decimal 0.4583. Porosity or the saturation as 1, and then E. So we now have here E is equal to 0.4583 G. Where can we use this so that we can get the value of G? Now take note, from the given we have mass over the volume. So what do we get if we have mass over volume? We get density. Density is equal to mass over volume. So since we are dealing with saturated mass and saturated volume, we have here gamma sat, or that is rho sat, equals the mass, that is 350 grams, and the volume, saturated volume, 200 cc. So how much is that? 350 divided by 200, 1.75. So gamma sat is 1.75 gram per cc. Now since we have rho sat here, the formula for rho sat is same with the gamma sat. Same with gamma sat. The difference will be the water unit weight. So instead of using gamma water, you will be using rho of water or density of water. So instead of gamma sat, you have there rho sat. Then instead of gamma water, you have rho of water. Okay, so we have here G plus E over 1 plus E rho of water. Rho sat is 1.75 gram per cc equals G plus E. What's the value of E a while ago? Here, we have the equation 1 here. E is 0.4583 G over 1 plus 0.4583 G. And rho of water is, so for rho of water in gram per cc, we have 1 gram per cc for rho of water. So that is 1 gram per cc. So let's distribute. So 1.75 divided by 1 is 1.75. So this becomes, so cancel this one out. 1.75 plus, so what is 1.75 times 0.4583? 0.8020. So 0.8020 gram, or specific gravity G. Then this becomes 1 plus 1.4583 G. Therefore, G now is equal to 1.4583 minus 0.802, that is 0.6563. That is what's that? 0.6563. 0.6563. G is equal to 1.75. G now is equal to 1.75 divided by 0.6563. So we have here 2.67. So 2.67 specific gravity. Okay, so specific gravity done. Next is porosity N. To get the value of N is equal to, N again, N is E over 1 plus E. So E over 1 plus E. How do we get the value of E? Here. Since we already have the value for G, therefore, we can get the value of E, 4583, 2.67. So E is equal to 0.4583 times 2.67. So 1.2237. Then we have here N is equal to 1 point. So 1.2237 over 1 plus 1.2237, and now is equal to, is it in percent? Yes, in percent. Times 100. So 1.2237 all over 2.2237 times 100. So 55.03. 55.03%. So that's the value of porosity. So that's for number 4. Right, so let's go to number 5. The moist weight of 0.2 cubic feet of a soil is 23 pounds. The 3 here is too little. Let's raise to 3. So the moist weight of 0.2 cubic feet or cubic foot of a soil is 23 pounds. The moisture content and the specific gravity of soil solids are determined in the laboratory to be 11% and 2.7 respectively. What is the moist unit weight in pound per cubic feet or foot? What is the dry unit weight in pound per cubic foot? And then what is the degree of saturation in percent? Okay, let's write first the given. So we have here the volume, moist volume is equal to 0.2 cubic feet, cubic foot, and then weight. So this is weight, not mass, 23 pounds. Moisture content is given as 11%, or that is 0.11. We have the specific gravity G, that is 2.7. So we're looking for the moist unit weight, gamma M, dry unit weight, gamma D, and the degree of saturation, S. Okay, let's start with the first one. So gamma M is simply weight over volume, that is moist. So moist. So gamma moist is equal to the moist weight of 23 pounds divided by 0.2 cubic foot. So what is 23 divided by 0.2? So that is 115. So gamma m, let's just write here, gamma m is 115 pound per cubic foot, or that is 115 pound per cubic foot. Next, B, dry unit weight. So how do we get the dry unit weight? Given moisture content, given specific gravity. So for the dry unit weight formula, we have here given G. So we have the formula for gamma D here already as gamma M over 1 plus MC. So we can already use that. Or you can use this one, G over 1 plus E gamma W, but there's no E here, so no E. So you can use this one. Gamma D is equal to gamma moist 1 plus MC. Okay? So gamma D is equal to gamma moist over 1 plus MC. So gamma D is equal to gamma moist 115 over 1 plus 0.11. So gamma D is equal to 115 over 1.11. So 103.6 pound per cubic foot, or PCF. You can have it in PCF. Okay, so we have here letter C. For letter C, we're looking for the degree of saturation in percent. How do we get the value of S? Degree of saturation S. Again, from the relationship GMC SE. Now the problem here is we are missing E. How do we get the value of E? That is from the formula of gamma M. Going back to the formula of gamma M, we have here, so for the formula of gamma M, we have GMC, and we are missing the E. Okay, but given gamma M, so we can still solve for E. So for the value of E, we can find it by using gamma M is equal to G plus GMC over 1 plus E gamma W. So gamma M is 115. So we got the value of gamma M. G, given G is 2.7 plus 2.7 times 0.11 for the MC, 1 plus E. Then gamma W in 115, in PCF, in pound per cubic foot. So we are using here English. We forgot to put here in English. So this is metric. So in English, we have here for gamma of water, so that is 62.4 pound per cubic foot, or PCF, in English system. So 62.4. Okay, PCF, or pound per, let's just emphasize that it's in pound per cubic feet. So this one is 115 pound per cubic. So cancel. So we now have here 115 divided by 62.4, 1.8429 multiplied with 1 plus E. So 1.8429 plus 1.8429E equals 2.7. So what is 2.7 plus 2.7 times 0.11? 2.997. 997. So E now is equal to 2.997 minus 1.8429 equals 1.1541 divided by 1.8429. So the answer for E is 0.6262. And what are we looking for again? It's degree of saturation. So we have here G, MC equals SE. The value of G is 2.7. MC is equal to 0.11. S missing. E is 0.6262. So S is now equal to 2.7 times 0.11 all over 0.6262. 0.4747. Is it in percent? Yes, we're looking for percent. So times 100. So that is 47.43%. So 47.43%. So that's for number 5. Okay, now let's go to number 6. For number 6, we have a cubic meter of soil in its natural state weighs 17.5 kilonewton. After oven drying, the soil weighs 14.2 kilonewton. Assume specific gravity as 2.7. Calculate the void ratio of the soil. So we're looking for the void ratio E. Calculate the degree of saturation of the soil, S. Calculate the saturated density of the soil in kilonewton per cubic meter. So saturated density in given unit, what unit is that? That is in unit weight. So the answer should be in gamma sat. Okay? So the unit is kilonewton per cubic meter. So it's gamma sat. Here are the given. The given is a cubic meter of soil. So that's the volume. Volume is 1 cubic meter. And the weight here, W, is equal to 17.5 kilonewton. It says here, natural state. So if we are talking about natural state, that is moist. So our volume and weight here are moist volume and moist weight. Then after oven drying, the weight, so weight dry, becomes 14.2 kilonewton, and the specific gravity G is equal to 2.7. Okay, so we need to find the void ratio E. So looking at this, we can solve already for moisture content. Then At this portion here, we have gamma moist. So if we have moisture content and gamma moist, formula for moist unit weight here is here. So we can use here the formula for gamma moist to find the value of E. Okay? So gamma moist is equal to G plus GMC 1 plus E. For letter A, we have gamma moist is G plus GMC over 1 plus E gamma water. Okay, so given the G. So let's find gamma moist. Gamma moist is equal to 17.5 divided by 1. So gamma moist is equal to 17.5 kilonewton per cubic meter. Okay. Then we have the moisture content as 17.5 minus 14.2 divided by 1. So moisture content is 17.5 minus 14.2, that is moisture content, that is 14.2. Oh yeah, why did I divide it with 1? Remember that for the moisture content, it should be the water over dry. So weight, moist weight minus the dry weight over weight dry. So that is 17.5 minus 14.2 divided by 14.2. That is equal to, so what is 3.3 divided by 14.2? So 0.2324. 0.2324. Okay. Now we have here gamma moist is equal to G plus GMC over 1 plus E gamma of water. So gamma moist is 17.5 equals 2.7 plus 2.7 MC 0.2324 all over 1 plus E gamma of water in kilonewton per cubic meter, and that is 9.81 kilonewton per cubic meter. Okay, so what is 17.5 divided by 9.81? 1.7839. So 1.7839 multiplied with this, 1.7839 E equals 2.7 plus 2.7 times 0.2324. 3. So that is 3.3275. And the value of E now is equal to 3.3275 minus 1.7839 equals divided by 1.7839. So the answer here for E, void ratio, is 0.8653. And that is E is equal to 86.53%. So it says here, so or. Okay, or. Next, we are looking for the degree of saturation of the soil, S. So we can now have here G, MC, SE. G being 2.7, MC being 0.2 0.2324 equals S. E is 0.8653. So S now in percent? No. Okay. So 2.7 times 0.2324 equals divided by 0.8653. 0.7252. So 0.7252, or that is in 72.52%. Next, letter C. What we're looking for on letter C, the saturated density of the soil, but in kilonewton per cubic meter. So we're looking for gamma sat. Gamma sat formula is G plus E over 1 plus E gamma W. So G plus E over 1 plus E gamma W. So gamma sat is equal to 2.7 plus 0.8653 divided by 1 plus 0.8653 times gamma of water, that is 9.81 if we are talking about kilonewton per cubic meter. So gamma sat finally is equal to 2.7 plus 0.8653 over 1.8653. Then we have here multiplied with 9.81. So the final answer is 18.75. Gamma sat is 18.75 kilonewton per cubic meter. Okay? So that's for number 6. Let's go for the last one for this video. Number 7. Now for this number 7, we have a sample of dry sand having a unit weight of 16.5 kilonewton per cubic meter and a specific gravity of 2.7. It is placed in the rain. Okay, imagine a dry sample, then you place it in the rain. So of course, it will soak up water. During the rain, the volume of the sample remains constant. Now, pause right there. Why does it remain constant? It's because the sample is sand. The soil sample that tends to expand when soaked with water is the clay, because the clay absorbs water and that soil sample expands. But as for the sand samples, the tendency is it remains constant as for the volume of solids, or as for the total volume, should I say. So the total volume still remains the same whether it is soaked or not. Okay, so the dry sample here is sand soaked in the rain. It is placed under the rain. Then the degree of saturation increased to 40%. Determine the following: the void ratio of the sample in percent, the unit weight of the sample after being in the rain, and the water content of the sample after being in the rain. Okay, so let's have the given. Okay, so first, what's missing here is void ratio E, unit weight of the sample after being in the rain. Unit weight of the sample after being in the rain. Is that gamma moist or gamma sat? Okay, let's investigate. Because we have two choices. Either it is gamma moist or gamma sat. If the soil there is clay, there's a possibility that all voids of that clay will be soaked, right? But here it is sand. So the possibility there is that this is the sand sample thus voids. So there are connected voids wherein the water pass through seepage, so it seeps out of the sample. So one scenario is that. Another one is, in the problem, it says there that during the rain, the volume of the sample remains constant, but the degree of saturation increases to 40%. It's not 100%. It says there the saturation increases to 40%. So S there is 0.40. So what we're dealing here is a gamma moist. So it's a gamma moist, not a gamma sat, due to the clue there that saturation is 40%. Next, for letter C, we are looking for the water content of the soil sample after being in the rain. Okay, let's go to the given. So, dry sand with a unit weight of 16.5. So, gamma, dry, 16.5 kilonewton per cubic meter. Specific gravity G, 2.7. Then, S, 40%, or that is 0.4. Okay, so let's solve for letter A. Voids ratio. You can get that from the formula of the dry unit weight and this one. G over 1 plus E gamma W. So gamma D is equal to G 1 plus E gamma W. So we have there 16.5 kilonewton per cubic meter for the gamma D. For the specific gravity, 2.7 over 1 plus E, missing E. And gamma of water is 9.81 kilonewton per cubic meter. Cancel this one out. So what is 16.5 divided by 9.81? So 1.682. So 1.682 plus 1.682E equals 2.7. So E is now equal to 2.7 minus 1.682 divided by 1.682. Okay, so E is 60.52%. So 60.52%. Next, letter B. We're looking for the gamma moist. So what's the formula for gamma moist? Gamma moist is equal to, are we going to use the SE or the GMC? So for the gamma moist, we are going to use the SE because S is already given. So G plus SE over 1 plus E gamma water. So gamma moist is equal to G of 2.7 plus S of 0.4 plus E of 0.6052 over 1 plus 0.6052 times 9.81 kilonewton per cubic meter. So the answer for gamma moist is in kilonewton per cubic meter. 2.7 plus 0.4, 0.6052 over 1.6052 times 9.81. So the answer here is 17.98. So 17.98 kilonewton per cubic meter. So that's for B. Next, letter C, moisture content. So how do we get the value for moisture content? Since we now have the value for G, S, and E, so we can now use GMC as E. G as 2.7. Okay, so 2.7 times the moisture content that is missing, S as 0.4, then E as 0.6052. So MC is now equal to 0.4 times 0.6052 divided by 2.7. So that is equal to 0.097. Are we in percent? So no. So that is 0.0897, or that is 8.97. Okay, so that's for number 7. Right, so that's all for this video. Please stay tuned for the part 2 and part 3 of the entire topic under properties of soil. Okay, so we have 1 to 7, and the rest will be discussed in the, or will be solved in the next video.